So the next question over here is we need to create a method to find nth element from the last node. So what does it mean? So let's say we have a single linked list like this and we want to find nth element from the last node over here. It means we need to return the element which is located nth step from the last node. So for example, if we want to find out the third element to the last, we are going to return the node 3 over here because it's going to start from the last element 1, 2, 3. For example, if you want to return the second to last, then in this case it's going to return node 4 because node 5 is the last node, which is the first, then node 4 is the second node over here. So hopefully the question is clear and you have understood that what we need to do in our question over here. Now there are many approaches to this question. We can write solutions in both recursive and iterative ways, but we know from previous lectures that recursive solutions are often clear but less optimal. That's why I will write an iterative solution over here. Here we need to take into account that the linked list size is not known, because if the size is known, we can return the nth element by returning the element which is located at the index of length minus n. So after finding the index of the element, we can just iterate through the linked list and find that location. Because this solution is so trivial, this is not what the interviewer intended. So that's why I'm going to use iterative approach over here. So this is more optimal solution, but it is less straightforward. The logic over here is we will use 2 pointers and set them to head. And then we place them n nodes apart in the linked list by putting first at the beginning of and the second one at the end node. Then by moving them at the same pace and stopping when the second pointer reaches the last, it's obvious that in this case first pointer will be on the node that which is located n step from the last. Now for example, if we are looking for second element to last, in this case it's obvious that we can easily see that it is node 4, because node 5 is the last element which is the first and node 4 is the second one. Now how can we do this? By using the iterative approach. Now here the first thing that we are going to do, we are going to create 2 pointers. So the first pointer will be set to node 1 and the second pointer will be set to node 2. Because in this case we are looking for second to last. So this means that second pointer will be located at the second node. So if we are looking, for example, for third to last, in this case we are going to locate the second pointer at the third node. So it depends on the n over here. Then we are going to move these pointers at the same pace. So if I move them one step, so in this case the pointer 1 will be node 2 and the pointer 2 will be at node 3. And this movement will go until the second pointer reaches to the last node. Now in this case we see that we have not reached the last node because the next reference of 3 is 333, so this means that this is the physical location of node 4. And in case of single linked list, we know that if the node's next reference is null, it means that this is the last node, so we are going to continue until we reach the last node. Now in the next iteration, the pointer 1 will be node 3 and the pointer 2 will be node 4, and we know that node 4 is not the last node in our single linked list over here. That's why we are going to continue one more node. So here when we continue one more step, you see that second pointer reached the last node. So this means that if the second pointer reaches the last node, the pointer 1 points to the node which is the nth to last. So in this case it's going to be the second to last. So here node 4 is second to last node in our case. So as you see before, we said that when n equals to 2, in this case node 4 is the nth to last. So that's why by using this iterative approach we have found the same node over here. Now based on this algorithm that we explained over here, we are going to create our method in Java. So we will implement this algorithm in practice. So let's head over to Java and implement it there. Now as you remember, in our first lecture of this section, we have created linked list class over here, in which we have 3 methods. The first method is for creating the linked list, then inserting a node to the linked list, then word traversal, and we have created questions class over here, in which we have implemented the previous question over here. Now after this method over here, which is solution to the previous question, we are going to implement another method over here, which is solution to the nth to last, which is question 2 in this section over here. So I'm going to use linked list class and node class that we created before for this method also. So our method will return the type of node, which is this class over here that we created before. and the name of method will be end to last. So as a parameter, this method will take two parameters. The first parameter will be the linked list, and the second parameter will be the integer n. So based on this n value over here, we are going to return end to last. So the first thing that I'm going to do over here, as we said before, we are going to create two pointers. So the pointers will be the type of node. So first pointer will point to the head, and the second pointer will point to head also. So as you remember, when we are talking about this approach, we said that second pointer has to be at the location of end node. Now in this case, to reach that location, we have to loop through the linked list to point pointer to that node. Then after reaching them, we are going to remove this pointer at the same place. So here I'm going to write first for loop like this. So it's going to be like this. Int I starts from 0, which will be the first node. Then it will continue until we reach the I less than n. So we are going to reach to this position because we are starting from the 0. That's why I put less than, not equal. Then it's going to be increased by 1 in each iteration. So here I'm going to write one if condition like this, because there might be a situation that pointer 2 might reach to the null. So in this case, we will just return null because this is out of bounds. So here I'm going to put if condition like this. If p1 is equal to null, in this case it doesn't make sense to continue, so I'm going to write return null. This means that it's out of bounds. Otherwise, we are going to set p2 next to p2. So here, after this loop, our second pointer will be at the location of end node. Then after doing so, we are going to move these two pointers at the same pace. So here I'm going to write while loop like this. So it's going to continue until second pointer reaches to the last node. So while p is not equal to null, which means that it does not reach to the last node. So here I'm going to set p1 equals to p1.next and p2 equals to p2.next. So when p2 reaches to the last node, it means that p1 is located end to last. So this means that p1 is located at the location of nth element from the last node. So here I'm going to return p1. So with this, we have completed our method. Basically what we are doing over here is we are pointing two pointers at the head, then we are moving the second pointer to the nth node in the linked list. Then after p2 reaches to the nth node, then we are going to stop there. Then we will start to move these two pointers at the same pace. So when point 2 reaches to the last node, we are going to stop over here because point 1 will be at the location of end to the last. Now with this, we have completed our method. Now let's see how this is working in practice. So here inside main class, we have created a linked list like this. Then I'm going to call this method for example, second location. Then I'm going to print out this node's value that returns from this method to see that how this looks like. So here, as you can see, after inserting some nodes to this linked list over here, we have called the traversal method to see the output in the console. So if I run our code, you see that our linked list looks like this. So we have created linked list like this. So the second from the last node is 4. So as you see, the value of 4 is printed out over here. So our method works the way that the question asked. So we have successfully implemented an answer to this question over here. Now you might be interested, what is the time and space complexity for this method over here? Now the time complexity will be on, because we have to loop through all nodes until we reach the last node, and the space complexity will be O1, because in this case an additional memory is not required to perform this method over here. Now with this, we have come to the end of this lecture. So hopefully everything is clear about this method over here. So see you in the next question.